So, Leonard Tramiel is a very good friend of mine. We have known each other for years and years and years since we got off that plane in Eugene, Oregon. Yeah, we were both going to the Skeptic Toolbox, which is a place where I kind of got my start. The Skeptic Toolbox in Eugene, Oregon. It's something that they used to do every year for a long time. It was people would, about 20 to 50 people would, maybe about 50 people would show up, and they spent the weekend together. We didn't really have internet. We didn't really have nobody had cell phones back in 2002, something like that, 1999. And we would spend the weekend at a college together. We eat, drink, everything was there. We stayed in the dorms, and we had cafeterias, and we just hung out. It was so much fun, and all the speakers stayed with us. All the speakers were there, and there were luminaries. Harriet Hall, well, she was later. Jerry Andrus, the magician, Ray Hyman, Barry Beierstein. These are people who started with the skeptical movement back in the day. They are people who were like James Alcott, just right at the beginning. This was something the Center for Inquiry did. And I flew up there one year after like 2 or 3 times, and I got off the plane, and here comes Leonard, walks off. I'm like, I kind of think I know you, you know? And so that's where we met, kind of, more or less. Why do you have that look of confusion on your face? You had a different story?
It's perpetual.
Okay. So Leonard is a very, very good friend of mine. He is brilliant and he's kind, even though he can be a little bit of a pain in the ass sometimes.
Only a little?
Yeah, and Jay's not here today, so we should have peace. So Jay and Leonard together are just impossible. So I'm going to let you hear from Leonard Tramiel. Come on up.
Thank you, Susan. So when Susan asked me to give this talk, because suddenly she had another day of SkeptiCamp, I wasn't sure what to talk about. I've given a few SkeptiCamp talks on different subjects, and I thought I'd do something different. So rather than sort of semi-lecture and be boring, I thought I'd try and bore you in a different way. So, as Susan alluded, I have been into astronomy for a long time. Astronomy has been my hobby since the 3rd grade, and I was in the 3rd grade, let's just say, a while ago. Not that funny. So yeah, I've been doing this for a while. I got interested enough that I wound up getting a PhD in astrophysics. So you might say I pretty seriously into this stuff. Most of what I'm going to talk about does not require anything resembling a PhD in astrophysics to understand and appreciate. So, you go outside now, facing in the wrong direction. If you go outside now, will you see the moon?
No. Stop.
Did anyone notice?
Maybe.
So Susan said, no, it's not dark.
Sometimes you do.
Sometimes, but
So
yeah.
there is a very common idea, and it's been part of human knowledge for a long time. I'm not going to quote the Bible correctly, but and God made 2 lights, the sun for the day and the moon for the night, which went along with, I'm not going to say caused, went along with the idea that you could only see the moon at night. So, here's the question. What fraction of days is the moon visible while the sun is above the horizon? This is not a rhetorical question. Raise your hand if you want to answer.
Oh.
Yes, Deborah.
25%?
25%. That is a number.
It is.
Yeah. 0.25, 25%, 1/4, all the same. Anybody else have a An estimate, yes, sir.
75%.
75%. That's very different.
Yeah.
Yes.
50%.
50%.
Yeah, closer to 50%.
About 50%.
Those are all numbers, very good.
These are all, not only are they numbers, but they're numbers that make sense in the context of the question. 400% would not make sense. That would be yes.
Isn't that what? Is this assuming you don't live in the middle of a, like, deep in a canyon or in a very mountainous area?
It does assume that. I also say ignoring weather.
Yeah, I saw that.
So if it's cloudy, that doesn't count.
Or there are trees.
Or there are trees in the way.
Or mountains.
Yeah.
Mountains, yeah.
right.
So if you were to go outside now and look towards the west, you would see the moon.
Mm-hmm.
I didn't actually check, but I'm confident.
Yeah. The
The answer is at least 80% of the time.
Wow.
It's probably a little higher than that, but it depends on how good you are at picking the sun out from the really bright sky near the sun.
Yeah.
So you can't just go outside at any time and see the moon every day. For example, the moon will set around noon today. So if you go out in the afternoon and look for the moon, it ain't there. But if you pick the right time of day, you can see the moon in the sky virtually every day. Yes, ma'am?
Does that vary, like, is it that much time every day that you can, like, if it's 80%, is it half of a day all of those times, or is it like a tenth of a day sometimes?
It may be a very short time.
Yeah.
So
When you have a new moon, I mean, it's just,
the biggest problem is the full moon.
yeah,
Mm.
The full moon rises when the sun sets.
yeah,
So the sun can't be in the sky when the moon is, by definition.
yeah.
For a crescent moon, it's very hard to see the moon because it's in the very bright part of the sky and there's this big thing in the way, glare of the sun. But it's there all day. You just don't notice it. Yeah. So,
In fact, there's some religious things where the timing is when you first see the new crescent moon, the first sliver, and so that's.
yeah,
that's
so
hard.
there are a few traditional calendars that are still used in some religious groups that are lunar.
Yeah.
And they base things on the lunar calendar. I believe still officially Ramadan
Yeah.
does not start until some high imam in Persia says, "Oh, there's the moon."
And it doesn't have to be at night then?
Oh, no, no, no.
No, it has. Well, you can't see it. It's a very very thin moon,
Yeah.
so it's so faint that you can't see it until the sun goes down.
Yeah.
So, and that's
It's a
one of
big
the
deal.
that's one of the reasons that it's not 100%.
No, that's why I wondered, I knew about the Ramadan thing, but I
Yeah.
just wondered if it was, okay, well, if you can still see it.
You won't be able to.
Except by earth shine.
That's even fainter.
Oh.
Yeah. So the illumination caused by Earthshine is much fainter than the illumination caused by the sun.
And there's some cultures where they actually don't recognize the moon in the daytime. They say the moon is up at night, and you go, look, there it is. You go, no,
No, that's not the moon.
that's not the moon.
Yeah. So one of the fun things I do at the observatory that I volunteer at, when appropriate, I will position myself outside at the dome, so that behind me is the moon
Uh-huh.
when I'm talking to the kids, and I'll say, "So, how many people have seen the moon during the day?" And virtually no one. I said, "Okay, is it possible to see the moon during the day?" And a bunch of no, you can only see the moon at night. I said, "Okay, what's that?" Yeah,
Aliens.
that's fun. It's not aliens. It's not always aliens. Yes.
I misread your question, but I was thinking of what percentage of the time is the moon visible while the sun is above the horizon?
Right.
And that should be 50%, right?
No.
No?
So the only time the
Maybe how many
moon
days?
isn't visible, while the sun is, what percentage of the time? Yeah, I can't work it out in my head, at the moment, but yeah, that's not the question. Therefore, I don't care what the answer is. All right. Obviously, when the moon is fully lit, it is brighter than when the moon is half lit. How much brighter is the full moon than a half moon?
Depends
Yes.
on how close it is to the earth.
Basically, not at all.
Oh.
So the entire supermoon thing is, you're gonna put this online, right? Not true. So there's two problems with the concept of a supermoon. One is it's bogus. The other is the term came from an astrologer. Therefore, even if it were correct, we shouldn't use it. So yes, the moon does have an elliptical orbit around the Earth, sometimes a little further, sometimes it's a little closer. Emphasis on the word little.
Yeah.
It is not a significant effect. So,
It's like the moon illusion, like near
yeah,
the horizon. Yeah.
that overwhelms
Yeah.
the actual
But, I mean,
angular size of the moon in the sky. Okay, so how much brighter is the full moon than the half moon? Yes.
about 20% brighter, I think.
So the
So the half moon is 80% of the full moon, I think.
so logically, it's half the moon.
Right.
So it should be half as bright. So the full moon should be twice as bright as the half moon.
Right. Should
So
be.
you're saying it's not that extreme,
Right.
okay? Does anyone want to go the other way, or say it is yet 50%? Yes.
What about the albedo effect?
What is the albedo effect?
Yes. When you have the full moon and it's, you've got obviously the sun on the other side, the reflection is brighter than when it's just a bit off. That's what I've read anyway.
Yeah. I've never heard the term albedo effect. Albedo is just the percentage of light that bounces off from what comes on. It's just the reflectivity. So the answer is it varies, but at least 6 times brighter. So 3 times more than you would naively think. And sorry, it's off, but in the other direction.
Right, okay.
And it's funny.
I could have read that
Um,
wrong. It's possible.
At first I'm going, why is there such a range? And one simple answer is the first quarter moon and the last quarter moon are showing different parts of the moon.
The Mario.
And the last quarter moon is showing most dark stuff.
Yeah.
And the other side is showing more light stuff. So the 2 half moons actually differ by a fair amount.
The albedo is different.
The albedo is different. And that has an effect.
I knew Al was famous astronomer.
Albedo?
Albedo, yeah.
Yeah. So why is there such a big effect? And the answer is, when we're looking at the full moon, we're looking at the moon fully illuminated. Everything facing us has sunlight on it. When we're looking at a half moon, we're looking at the moon lit from the side. And lots of the moon, when lit from the side, is in shadow. So this crater is called Tycho. And Tycho does not look particularly dramatic in this photograph. It's got a really nice central peak, but it looks sort of like all the other craters.
And there's the Terminator.
And on the left side is the Terminator, and that's the line between light and dark. And you can see that a lot of dark over there. So all of that stuff subtracts away from the illumination. This is what that section of the moon looks like at full moon. Can you find Tycho?
Yeah.
It kind of stands out.
Yeah. Yeah.
It is in fact impossible to miss. Now these are not exactly the same parts of the moon. Couldn't find pictures that exactly match, but Tycho is superimposed pretty well between these 2 pictures. and the moon looks quite different. It's very bright. So just something you probably didn't know, and I thought was surprising.
So it depends on which half, too.
And it does depend on which half, but in both cases, it's less.
1/80th. Sorry.
So as I was going to say, the answer to this question was accidentally blurted out by Milos in his talk yesterday. You actually mentioned it in your talk yesterday.
Oh God, so that means
And I
we're supposed
thought
to
you
know the
had gotten it
answer?
out of you, but apparently not. So the moon is a quarter the diameter of the Earth. So if the moon had the same density, don't answer. If the moon had the same density as the Earth, what fraction of its mass would it be? Yes, this is a math question.
Does it have an
It
8 in
does
it?
not require a PhD in astrophysics.
16?
So we have 1/16. We have a mad calculation. We have pen and paper being used.
Oh, there are arrows and
Not yet. There are circles. I see circles.
a while.
circles and arrows and
And a paragraph at the
paragraph
back.
under each one.
So, to save you time, the volume of a sphere is 4/3 pi r cubed. The volume of a thing goes up by the cube of the linear dimension.
Right.
So 4 times 4 times 4 is 64. So it is 1/64th the volume of the Earth. But because the moon doesn't have as much iron in it, because when Theia, the roughly Mars-sized thingamabobber, that slammed into Earth,
Earth
which
1.0.
merged for a little
Earth
while,
1.0.
slammed into what, there isn't a good name for that. We'll call it proto-Earth,
Proto.
maybe?
Yeah.
The thing that Theia hit?
Yeah.
The target. The cores largely coalesced to form our core, and the debris splashed out to make the moon. So there's not as much heavy stuff in the moon. So instead of being 1/64th, it is 1/80th.
I have a great animation of that. Ah, it's beautiful.
I don't.
It sounds
So
nice.
and it's got sound effects.
Yeah.
So another fun thing about the moon just fell out of my head, but yeah, so it's I found that surprising. So do you think that makes the moon really, really big or pretty small? It's 1/80th the size of the mass of the Earth. So have you heard of the asteroid belt?
Yes.
Raise your hand if you think you've heard of the asteroid belt. All right.
Oh God, it's gonna be a trick. It doesn't exist, right?
And you've all seen pictures and videos and depictions in movies of asteroid belts. There are these places that are just jumbled with rocks slamming into each other. You gotta zigzag to go your way through.
No.
So if you took all of the asteroids in the asteroid belt, one of which is 400 miles in diameter, and you combine them all together, what would the ratio between that mass be and the mass? Oh, we'll make it easier. Which is bigger, that mass or the mass of the moon? The moon. Yeah, the asteroid belt is basically empty. At the densest point in the asteroid belt, the distance between asteroids is 1 million miles. Every time we have flown something through the asteroid belt to see an asteroid, we had to pick the trajectory or move to find it. Do not get your planetary configuration information from Star Wars.
Yeah.
Just not the right way to do it. All right. The sun has an activity cycle. It goes through this cycle once every 11 years or so. It's actually a 22-year cycle because the north and south magnetic pole of the sun flips every cycle. So it goes up with the North Pole at the top, and then goes down, and then it flips. Actually, it flips here, goes down, and the South Pole. But the activity goes up and down. That does have an effect on the brightness of the sun. How big an effect?
You mean when it changes polarity?
No, at high activity and low activity. Now, activity
Okay.
is magnetic storms
Solar maximum, solar
which
minimum.
produce sunspots and other things. Everyone know what a sunspot is?
Yes.
A little black dot on the sun. Not from the Police song. Little black dot on the sun. But it's so you get these black dots on the sun, and during solar maximum, there's more of these black dots than there is at solar minimum. That was deceptive. I was trying to fool you.
11%.
1/10 of 1%. So anytime you hear a climate change denier say, oh no, all this is the result of the sun. First, the correlation does not exist.
Right.
If you look at the 11-year cycle, there is no 11-year cycle with regard to the climate, so that's wrong. And the effect is backwards. During maximum, the sun is brighter despite more sunspots. How can that be? How can the sun be brighter when there are more sunspots?
Because the corona of the sun has more
The corona is really, really dim, so it's not the corona. Good thought.
photosphere.
Good thought. Well, the photosphere is the bright part. It turns out that there are other things that happen on the sun besides sunspots that are brighter, and they make up for the dark parts. But because when you're looking at the sun, it's hard to see anything at all, and when you're looking through a filter that makes it dim enough to see well, the sunspots show up easily, but the bright parts don't. In our solar system, what planet's surface is the hottest?
Venus.
Venus. Are you sure?
I don't want to say anything because I think everything I know is wrong now.
Mercury.
I'm
Not
worried.
quite. You're
I'm
almost
worried.
everything except for that statement.
Mercury.
So Mercury is half the distance to the sun compared to Venus.
But
So it gets 4 times the solar radiation. And, more deceptive, true information, the cloud cover on Venus is so thick that on the surface, the solar illumination is about equivalent to a full moon on Earth. But despite that, Venus, the average temperature on Venus is higher than the highest temperature on Mercury. Now, what might surprise you is the range on Mercury. So Mercury is sort of kind of locked into its rotation around the sun. It's a 3-to-2 resonance, which, for funny math reasons, means that a solar day, the amount of time it takes for the sun to go around the sky, is actually 2 years. So Venus is if you're on Venus in a place where it's dark, it's going to stay dark for a long time. So the backside of the dark side of Mercury is actually colder than the dark side of the moon because it just has so much time to cool down. And the other side is really hot, much hotter than the hot side of the moon, but still not as hot as Venus. Yeah.
2 Mercury years?
2 Mercury years.
Okay.
Yeah. So Do not visit Venus. If anyone offers you a all expense paid trip to Venus, so hotter than the inside of a self-cleaning oven. The atmospheric pressure is about 100 times what it is on Earth. The air is mostly carbon dioxide, which is why it grabs retains so much heat. And although the particles, the raindrops from the clouds don't make it down to the surface, the clouds are sulfuric acid. So, not great. Not visit. So Venus and Mars are both about the same distance to Earth every once in a while. That's why all the talk is to go to Mars, because Mars isn't trying to kill us quite that vigorously in as large a number of ways, which isn't to say that Mars isn't trying to kill us. Well, I'm not sure about trying, but it would do it anyway. All right. What's a day?
Depends on the planet you're on, right?
On Earth.
Oh.
What's a day?
Okay, like, how long?
Yeah, no. What is the definition of a day? And is there more than one?
Yeah.
So give me a definition of a day, or tell me what the definitions of a day
Sunrise
are.
to sunset, to next.
Sunrise
Sunrise to next sunrise.
to next sunrise.
Or sunrise to sunset, like day or night is in when it's light out versus when
Yeah.
it's dark out.
So astronomers never mention that unfortunate fact, that there's roughly half the time when you can't do anything useful.
Yeah.
Because this big light polluter is out. So day is the time from the annoying part back to the annoying part again. Yes,
There's a sidereal day too, which is 23 hours and 56 minutes.
approximately. We'll get more precise. So there's the sidereal day, and what we were just describing, the solar day. But the solar day is not what you just said. The solar day is not from sunrise to sunrise. Better to go from noon to noon, or from when the sun passes the meridian, the line between north and south. That varies through the year. Sometimes of the year, the maximum deviation is about 20 minutes. So some days are 20 minutes longer than other days. So which day do we use to define day?
The equinox.
The average. And it's not quite the equinox.
No?
And
I mean-
interesting,
I mean, like during, on the equator during the
yep,
equinox.
so that doesn't work either because the Earth doesn't have a circular orbit.
That's true.
So you have another factor. So the average solar day is 24 hours. And for a while, that was the definition. Then somebody clever noticed that sort of drifts and it's a problem. So we find more precise time by the most accurate timekeeping mechanism known to man, which at the time was the rotating Earth. So you would have observatories next to harbors that had what are called transit telescopes, which would time when stars went past the meridian, the line between north and south, and those were used to set navigation clocks, which were essential for finding your distance east-west, something called the longitude problem. All sorts of interesting history in there, which we can go into more if anyone has any questions. And unlike the mean solar day, as opposed to the friendly solar day, the sidereal, with respect to the stars, is 23 hours, 56 minutes, 4.09 seconds. And mostly through laziness, I haven't bothered memorizing it any further than that. I used to say 4 seconds, then 4.1 seconds, now 4.09 seconds. I don't know what that says about me, but whatever it is, it's probably not good.
And it's changing too, because we're slowing down.
So as the Earth and Moon interact, the Moon is being flung out into space by about that much per year. That increased angular momentum of the Moon comes from the rotation of the Earth. So the Earth is slowing down. A couple 100 million years ago, there were 400 days in a year because the year didn't change much, but the day did. And we know, how do we know that there were 400 days in a year?
It's on my calendar.
A couple of 100 million years ago.
Okay.
Fossil record.
No calendars lasted that long.
Fossil stuff, corals.
Yeah, so corals have the equivalent of rings, and you can see the annual rings and the daily rings, and you count daily rings within annual rings. I do not want that job. All right. So we had the solar day and the sidereal day, and 4.09 seconds, and if you want, you can look it up. There's more numbers, and it does change, and it's not always slowing down. As the planet warms, the ice caps are melting. This moves more mass towards the equator, shifts the balance. Things happen. It's not that steady. So because of this problem of the uncertain precision, when the day was defined with respect to the sidereal day, they picked a day 100 years ago when they were pretty sure it was longer than it would be any time now, and they were wrong. So that means they only would need to have leap seconds. But we haven't had a leap second for several years because it's actually speeding up instead of slowing down, and they're getting all pissed off. Most people don't care. Yeah,
I wonder if maybe this is what you'll say at the close.
never.
Why is it important for people to know this trivia?
Did
I
I say?
hesitated before.
Did I say it was?
I thought maybe there was something more that you'd like to say about.
We can talk about that later.
Well, one of the things, there's an article not too long ago about how the Chinese, with their Three Gorges Dam, is causing a disruption in the Earth's rotation because of all that water being concentrated, and of course people get all worked up, and so.
So that's just because they want to have reasons to get mad at China.
Yeah.
Not that they need other reasons.
But that's one of the reasons to know some of these things, to be able to have a critical look at some of these headlines grabbers.
Wait, you don't believe everything you read in the headlines?
Well, we hope people don't.
One of them. All right. So this effect exists not only for the Earth. So there are sidereal and solar days on all the planets. So does Earth have a particularly large deviation between sidereal and solar days? Or is it typical? Is it small? What do you think? Don't everyone answer at once.
Uranus has a real.
Uranus is messed up because it's like that.
Yeah.
So, but it's not exactly pointed polewards. So if you look at the equator, you have sidereal and solar days that almost behave, but the sunlight goes all over the place.
What about the moon?
Moon is not a planet.
Well, all right.
So in the case of the moon, we have another problem.
Yeah.
What's a month?
Yeah.
So first, of course, the word month used to have another O in it. It was a month.
Yeah.
Because of how long it took for the moon to go around its cycles,
Well, that is a cool piece of.
which
trivia.
is 29 days.
Let's go back to using that, I like
Oh, yeah, I don't. It's a good one. So, if you go, from full moon to full moon, it's about 29 days. But the time it takes for the moon relative to the stars, the sidereal month, is 27 days. 2 days different. And that's because of the Earth, Moon, Sun interactions. So how about for the other planets? Don't distract me until you do next, which is great. I told you. I asked if you were prepared to heckle, and you said yes, and you were honest. Anything else? What do you think?
More extreme on other planets.
So, for Mercury and Venus, we have the most bizarre situations. So Mercury, as I said before, I actually gave you this. Mercury rotates in exactly twice for every 3 times it goes around the sun, or maybe it's the other way around. So you have a sidereal day of 56 Earth days, and a solar day of 176. And interestingly, the ratio of sidereal day to solar year for Mercury and Venus is almost exactly the same. It's 2 to 1 in both cases. But in the case of Mercury, it is exact because it's tidally locked. In the case of Venus, it's close to 1.9. For Mars, the difference between sidereal and solar day is 2 minutes. For the other planets further out, well, for Jupiter, Saturn, and Neptune, it's vanishingly small because they revolve really slowly and they rotate really fast. So not much happens. For Uranus, because it's kicked over on its side, it's just weird. If Uranus is upset about this, just have it talk to me. I'm all right.
It's afraid they're gonna exclude it like Pluto.
Never. Oh, by the way, how is that planet actually pronounced? Not Pluto, the one I was just talking about.
Uranus?
So there are 2 terrible ways to pronounce that planet. There's Uranus, which as far as I'm concerned is just a piss poor name for a planet.
Yeah, it's so sad.
Or there's Uranus. And then you get all the jokes about the rings around Uranus.
Yeah.
And that's just, that is impolite.
Yeah.
So I like, when I think about it, which is not always, to pronounce it the way it's pronounced in Spanish, which is Uranus.
Oh, I
Which
like
is
that.
much closer to the original Greek.
I like that.
As near as we can tell.
Uranus.
So Uranus, which
Uranus.
is neither a piss poor name, nor do you have to worry about the rings around your names. All right. So here's getting more astrophysics-y. Stars range in mass over a far smaller range than they range in brightness or volume or lifetime. By how much? Anybody know what any of these numbers are? This fascinates me because the discrepancy is enormous. Anybody have any guesses? And I appreciate that this will be nothing more than swag. Stupid well-asked guess. Yes.
Green.
Green. Excellent. That
Great
is
answer.
as good a guess as I would anticipate. Thank you, Karen. Yes.
100.
100. Units, please. All right.
Greens.
100 green?
Yes.
So the mass in solar masses ranges from 1/10, smallest star is about 1/10 the mass of the sun, largest star about 100. Diameter ranges from 1/10 to at least 1,000, so a 10 times larger range. So stars have this big range there. Brightness from 1/10 of 1% to 1,000,000. So some stars are these little dim things, and some stars are these blazingly bright things. And lifetimes range from 1 million years, which relative to the sun, where it's about 10 billion, to 1 trillion years or more. So huge range. So why? And how do we know? Who figured this stuff? I'm going to use another word. How do we figure this stuff out?
Do we still get the point if we don't know their name?
Physics.
So, what group of people determined what stars are made out of, designed the classification system we use for stars, and figured out how to infer the distance?
Astronomers?
And the answer is on Milos's shirt.
A woman.
Stand up.
Woman.
Woman in science.
Women.
Yay!
Yeah, the answer is women.
Wow.
So I'm going to mention 3 of them because they have fantastic names.
Great names. Great names.
And they did some really amazing stuff. So a little bit more than 100 years ago, around 1900, a young woman, and they were all young, and yes, all women, by the name of Annie Jump Cannon, designed a classification system of stars based on the characteristics of the lines in their spectrum. And they knew which lines corresponded to which elements because they could try it on Earth. And virtually all stars had very obvious hydrogen lines, so they used that. And the classification system went from A, for most obvious hydrogen lines, down to L, for least obvious hydrogen lines, in alphabetical order. Then, someone named Henrietta Swan Leavitt, who probably classified more stars and personally added more information to the annals of astronomy than anyone to this day. She could classify stars' spectra and estimate their brightness to an astonishing degree of precision in a few seconds. And she went through thousands of glass plates. And she noticed, looking at plates from the southern hemisphere, looking at the large and small Magellanic Clouds, which are galaxies orbiting ours, 150 or so thousand light years away. Some of these stars varied in brightness. Oh, she also discovered variable stars and came up with most of the characteristics of them. And she noticed that for a particular kind of variable star, called a Cepheid variable, named after a star in the constellation Cepheus, that the brighter the star, the faster it pulsated. And this law, observation, was just exact. It was just remarkably precise. And you could only do that by looking at stars whose distance was all the same, not known, but the same. Because if they're all the same distance, and there's only 2 reasons that that the brightnesses could differ. They're all the same distance, so it had to be because they were actually brighter or dimmer. So by looking at just stars everywhere in the sky, you couldn't tell, but she had the obvious and brilliant idea. Those are my favorite.
Yeah.
Ones that, ideas that are, duh, why didn't I think of that? Because you're not a bloody genius, that's why. So this is now called Leavitt's Law, and it is used to this day to figure out the distance to distant galaxies. And it's a part of the cosmic distance ladder to determine the structure of the universe. Yes, do you have something to add?
That was one of my favorite definitions of genius, the ability to see the obvious before anybody else.
To see the obvious despite the fact that it's been slapping everyone in the face for centuries. Yeah. And then Cecilia Payne Gopushin, I don't know the right pronunciation.
Uranus.
Yeah, but she wasn't Spanish. So, she wrote a PhD thesis in the early 1920s, where she attempted to use the best science available at the time, this rather obscure and frankly bizarre bit of physics called quantum mechanics, to analyze what the composition of stars actually was based on what we know about their temperature and their spectral lines. And she determined that stars were mostly hydrogen. Now, everyone at the time knew with 100% certainty that stars are made of the same stuff as Earth. Earth is not mostly hydrogen. Therefore, stars were not mostly hydrogen. Turns out that there is an error in that extrapolation. When it was discovered through more analysis, not more careful analysis, because you could not have been more careful than Cecilia Payne was. Her thesis was called undoubtedly the most brilliant PhD thesis ever written in astronomy. And I have not heard anyone claim that a different one has taken that pedestal, because it's just remarkable. The understanding of how stars work, that was sort of a side effect of Cecilia Payne's work, caused us to realize that the ABCD ordering of Any-Jump Cannon's classification was not in the right order. But they left the classification names the same. So now the order from hottest stars to dimmest stars follows the obvious pattern of OBAFGKM, which everyone can remember instantly. And if you can't, it's easy. There is a easy and somewhat sexist acronym. Oh, be a fine girl, kiss me.
Lisa tonight, yippee.
And when you go past M, there are multiple different things. One of them is RNS for right now, sweetie. So there's lots of different, but oh, be a fine girl, kiss me is common to all of the acronyms. I'm sure there are better non-sexist ones.
Well, you can do "Oh, be a fine guy" and "Kiss me, Larry" tonight, and then either yippee or yuck, depending on how Larry.
Yeah, there are options, but that just I'm looking for a gender neutral way to put it, and possibly one that doesn't involve osculating.
Oh.
What do you got against kissing?
Nothing, but it's not supposed to be part of astronomy.
Of course,
Gee, no
it's
wonder I
dark.
have more people sliding the
It's dark. You're in the observatory. What
But it
else? I
started
mean, come on.
nighttime.
All right.
If you're
So-
not heterosexist.
It's
you
cold.
would
You have to
have
huddle.
that objection.
If it's cold, you have to huddle.
Yeah, spooning in the everything.
Spooning's good.
Gotta
But
keep
it's
warm
hard-
at night.
It's harder to kiss that way. But anyway, we're not going to get there.
Yeah.
So let's say you're trying to analyze stars. So you do what physicists and many scientists in general do. You make a plot. And you plot on the x-axis, horizontally, the color of the star. Let's put the red ones on the left and the blue ones on the left, the red ones on the right, and then the brightness. You put the dim ones in the bottom and the bright ones at the top. And you do that for several thousand stars. And you get that. And that tells you nothing. It looks pretty random. So, do we make a mistake? Or is there in fact no information in this? What do you think?
No, there are these ones that are kind of,
So, the vertical lines
Yeah.
are basically because people tend to gravitate towards certain colors. They'll say, yeah, that's red. So they're actually fuzzier. So there's a little fuzz on every one of those dots. So is there an important effect that we're missing that may have distorted our view of the beautiful underlying physics? And yes, the underlying physics is beautiful. Yes,
distance.
distance. Yes. So if you have two stars that are the same brightness and the same color, but one is twice as far away as the other, the further away one will look a quarter as bright. So that messes you up. So you adjust the distance using, for example, Levitt's law to tell you how far away things are. So if you have a cluster of stars, and one of them is a Cepheid variable, you can figure out the distance to that cluster. So if you do that, and it's hard, and it took a long time, and you have to be really careful, you get that. It is no longer random. Most stars live in this stripe. And then there's some others. There's a few over here. There's a bunch up there.
And faint is now feeble,
Excuse me?
feeble instead of faint.
Yeah,
Or feeble.
it says feeble. I'm not going to make a value judgment. Yeah.
Is that like a Hertzsprung-Russell diagram?
That is not only like a Hertzsprung-Russell diagram, that is a Hertzsprung-Russell diagram. So the first guys to do this, working off of Levitt's law,
Don't remember their name though.
Edgar Russell and I forget Hertzsprung's first name, but yeah, Hertzsprung-Russell. They figured this out. And at about the same time, we figured out how stars work. Fusion on the inside, some convection, cooling, all of this stuff. And if you treat stars as mostly hydrogen, doing this stuff as a result of gravity and nuclear physics, it turns out they're really simple. And all stars of the same mass, over a pretty wide range of characteristics, will have the same brightness and the same color. And if you do all the calculations, you get, they will be on this line. So that is what's called the main sequence. Small stars turn out to be red and fairly faint. Big stars are blue and hot. Why? So what is a star? I have a very dramatic way of describing a star. Does not involve jumping or anything, it's not drama that way. A star is a hydrogen bomb too big to blow itself up. So you have this enormous, continuous thermonuclear explosion going on in the center, trying to blow this thing to smithereens. At the same time, you have gravity holding it together. And this turned out to be stable until you run out of fuel in the middle. As you increase the amount of mass, there's more gravity. And remember, the mass goes up as the cube of the volume. So you get a little bit bigger, lots more gravity. So you have to fuse quicker to be stable.
Shorter
So you
lifetime.
burn through your fuel faster, and you gotta be hotter. So all of that fits with this. Then weird stuff happens, and the center collapses. You start fusing helium. The outer parts get ejected off, become a red giant, and this happens for stars all along this continuum, but the bigger the star, the sooner it happens. And they wind up in the upper right corner as red giants. So everything we know about stars is both encapsulated and confirmed by that one diagram, which is kind of awesome. So how do we know it's right? You can't build a star and check. But there's a couple of things you can do to, I don't know, look. So let's say you have a whole bunch of stars that were all born at the same time. If it's a long enough time, the diagram shouldn't look like that. It should look like this. You got that diagonal, but everything that should be in the upper left has warped over to the red giant. And that's a cluster of stars that shows this characteristic. And as you look at other clusters of stars, they have the same shape, but they turn off at different points. Everything is completely consistent, which is kind of fun. So how do we know the mass of a star? So I joke with the kindergarten kids that I see at Chabot. I ask them, how do we know the temperature of a star? I ask them, do we take a thermometer and stick it under the sun's tongue? And they laugh. And I say, well, of course not. We can't do that because the sun doesn't have a tongue. There are other problems as well. We don't use an anal thermometer. So they don't have a tongue. Our arms are too short, and the thermometer would melt. So look, there are other problems as well. So how do we know the mass of a star?
Gravity?
Compared to, but gravity doing what?
Moving the planets around it.
Well, until recently, we didn't know about planets around other stars. So we didn't find any of those until 1995 for the first really well-confirmed ones. So the laws of planetary motion allow you to infer the mass of a star for multiple star systems. So not stars with planets going around them, but stars with stars going around them. So there is this star called Algol. Algol is a distortion of a Arabic phrase meaning demon star.
Ghost. Hunter, okay? Oh.
It's a variable star. If you look here, this is fainter than that by about a factor of 2, and every roughly 2, a little bit less than 3 days, it goes from that to that for a little while, stays like that for a while, and goes back. There is no written record of this prior to 1667 anywhere on the planet. But it was called the demon star. Somebody knew something was up. But for reasons, no one noticed. So what's going on? That. It's a double star. One's brighter than the other. It happens to be arranged so that one goes behind the other. And when the bright one is blocked by the dim one, the brightness goes away. Which is kind of cool.
Is that called an eclipsing binary?
That is called an eclipsing binary. And we know the period of this to a factor of 1 in a million. Couple of seconds, yeah.
So, it seems like that only works if they're oriented.
Yes,
toward
most
the
double
sun,
stars,
right? Like
most
everything-
double stars won't give us this clue.
Yeah, they're doing this.
Yeah, but for Trinidad, there's a lot of stars, so we can do this. Okay. If you look at the arrival time of these minima, you get a graph that looks like that. It's 8 minutes later or earlier on different months. Why? All of you know the answer. Yes?
Because we're on the other side of our distance is one solar.
Yeah, because they're on the other side of the sun. And it takes 16 minutes for the sun to get the light from that star to get when we're far than when we're close. And in the middle, it's only 8. So all this works. And just because I know someone will care, these images and information about Algol is from a website of the Calgary Center of the Royal Astronomical Society of Canada.
Yeah.
I thought somebody might be interested in that. What's the ratio of the sun's volume to the Earth's? And notice I didn't say how many Earths can fit in the sun, because the Earths don't get well packed, so it's a volume. And the answer is about 1 million. What is the ratio of the sun's volume to Jupiter's?
1,000.
1,000, yeah, I pushed the button.
I knew that.
How many stars can be seen by the naked eye?
6,000.
You go outside on the darkest, clearest night, and you look up, and you wait for your eyes to adjust, and you, for some strange reason, count the stars.
Yes.
So we have 6,000.
Oh, way more than
Here in Vegas, only 3.
2 to 4.
We have 2 to 4,000. According to Neil deGrasse Tyson in New York, it's like 6.
Yeah.
Randy said 3 in Vegas.
3 in Vegas. Now, obviously, people used to think there were a lot more. You have a line in the Bible, I will make your descendants as numerous as stars in the sky. Thanks. So the answer is a few thousand. And it's not clear why people think that number is so low. I mean, most people don't realize the number is that low. Most people will go, oh, millions. No, just no. So I thought I'd end on a fun, simple one. So I did. Thank you. And if you have any questions, and we still have time, which we do not, we will go on.